In this section, we'll look at solving linear systems by elimination. Now, solving by elimination allows us to simplify our system of equations to a single equation involving a single variable. Now, up until now, we've been using substitution to do this. But with elimination, we'll eliminate one variable using simple addition or subtraction. We'll see how to do that in a second. So let's take a look at the following. We have 5x minus 3y equals 7. And we have 2x plus 3y equals minus 9. All right, so this is our system of linear equations. We have equation 1 and equation 2. Okay, so far in our bag of tricks, we have solving linear systems by substitution, where we would solve one equation for one variable in terms of the other, and then would plug that variable or that expression in for the variable into the other equation, and we'd actually get a value for one variable, and then we can plug that value into either equation to get the value of the other variable. All right, so in this section, we're going to use what's called elimination. Now, what we're going to do is we're going to use the form you learned in elementary school for addition, keeping the x and values lined up in their own columns. What we're going to do is we're going to have 5x minus 3y. It doesn't matter which one's first and which one's second, but we're going to add these two equations together. If you recall, when we first learned about addition, way back in elementary school, that when you add one thing to another, it doesn't matter which one you do first, but you would get a single value whenever you added them together. Here, we're going to be adding two equations together, and we're going to get another equation. And that equation is just going to be in terms of one variable that we can find a value for. So let's go ahead and do this. So we're adding these two equations and we're lining up our variables like so. We have the x's lined up, the y's lined up, and the c terms lined up on the other side of the equal sign. Now note, we need this in standard form so all the variables will line up. So these are already in standard form, so we're good to go. All right, so let's go ahead and add these. So straight top to bottom, we have 5x plus 2x is 7x. We have minus 3 plus 3y, which gives us a 0y. These terms actually cancel, but just for the first couple of examples, we can put 0y as a placeholder so we don't get confused here. And then we have 7 minus 9 is a minus 2. This gives us 7x. We can drop the 0y now, equals a minus 2. Let's go ahead and divide both sides by 7. And that renders an x equals minus 2 over 7. So this actually, in some ways, is a lot quicker and a lot simpler than substitution. We actually already have a value for one of our variables. So like before, we can take this value and we can plug it into either equation to get the value for the other variable y. So let's go ahead and plug it into the second one. Let's see, we have 2 times x, which is a minus 2 over 7, plus 3y equals minus 9. All right, so let's go ahead and solve this. We have minus 4 over 7 plus 3y equals minus 9. Let's go ahead and add 4 over 7 to both sides. We want to start moving everything to the right side except for the variable. These two terms cancel. That'll give us 3y equals, let's go ahead and rewrite 4 over 7. Excuse me, that's 4 over 7. Let's go ahead and rewrite 4 over 7 minus, let's write 9 as 63 over 7, so we can combine these fractions in the next step. That gives us 3y equals, this is minus 59 sevenths. We can divide both sides by 3 to isolate our variable. We can divide by 3 over 1 here. These two terms will cancel, so we have minus 59 over 7 times, instead of dividing by a fraction, we flip it and multiply. So we have 1 over 3. That'll give us y equals minus 59 over 21. And that's our value for y. So much quicker, a little simpler sometimes, as long as it's in the proper form, because if you notice, the method of addition works when the coefficients of one of the variables are opposites. We have the y variables right here, and the coefficients are minus 3 and plus 3. So that allowed us to cancel these. Later on, we'll learn how to manipulate equations to get this form when coefficients of one variable are not opposites. But in this case, they were already opposites and it worked out nicely. So let's go ahead and state our answer. The solution to this system of equations is minus 2 over 7. We have our x term. Our y term is minus 59 over 21. This is the point on the Cartesian plane where these two lines intersect if we put them on a graph. And we can actually plug both these values in for x and y respectively, and they'll work out for both equations. All right, so we're continuing to solve linear systems by using elimination. So let's look at the next one. We have x plus 2y equals 5 and minus x minus 4y equals 7. All right, so this is our system of linear equations. We have equation 1 and equation 2, so let's go ahead and add them together. We need to simplify this one a little bit, but then we can add them together and see what we get. So we have x plus 2y equals 5. If we distribute this minus sign, that'll give us minus x plus 4y equals 7. So let's go ahead and add these two equations together. And notice we can do this because one of the coefficients of one of the variables is the opposite of the other. We have 1x, we have a positive 1x and a negative 1x. So addition will work here because these two terms will cancel. If you want to go ahead and put 0x for this last example, we can actually do that for a placeholder, but we really don't need it. So we have 6y equals 2 plus 4 is 6, 5 plus 5 is 10, which gives us 6y equals 10. We can divide both sides by 6 to isolate our variable. That'll give us y is equal to 10 over 6 can reduce to 5 over 3 if you factor out a 2 out of the top and the bottom, and we have our first value. So let's go ahead and plug y into either equation. This one doesn't have a negative or a parentheses, so let's go ahead and use this one. It's fairly simple. It's already almost solved for x. So we have x plus 2y, y is 5 over 3, equals 5. Now we can go ahead and solve for x. So we have plus 2 times 5 is 10 over 3 equals 5. We could subtract 10 over 3 from both sides. That'll get x by itself. So we have x equals, let's transform or convert 5 into 15 over 3, which has a common denominator, so we can combine these two fractions. That'll give us x equals 5 over 3, or 5/3. Okay, so here's our value for x. Now we can go ahead and state our answer. The solution to this system of equations is 5/3 and 5/3. All right, nothing special about it. Both terms are the same, but this is the point where these two lines intersect. All right, let's go ahead and do one more. Let's say we have the system of equations 3x plus y equals 1 and minus 2x minus y equals 2. All right, this is our system of equations. Equations 1 and equation 2, so we can actually add these, because if you notice, we have a positive y and a negative y, so these will actually, we'll be able to cancel those terms and just be left with one equation with one variable. We have minus 2x minus y equals 2. We add these. 3 minus 2 is just 1x. These two terms will cancel. One more time, we can write the plus 0y if you want to. 1 plus 2 is 3. That'll cancel, so we have just x equals 3. We very quickly have our first value for our variable. So let's go ahead and plug it into one of the equations. This has negative signs, so let's actually plug it into this. 3 times x. So 3 times 3 plus y equals 1. That'll give us 9 plus y equals 1. We can subtract 9 from both sides. These two terms will cancel, which just gives us y equals 1 minus 9 is a minus 8. And we have both of our values. So let's go ahead and state our answer to the solution. The solution for the system of equations is 3 and minus 8. And we can check this. It's actually a good practice to do. If you want to plug these values in for both equations, they'll both equal out. So we'll do plenty more of these just to get a really good handle on it. You can see that it actually saves a bunch of time, but the only key here is that we need the coefficients of one of the variables in both equations to be opposites of each other. So we'll look at a few more of these in the next section, and then in a future section we'll look at what we do when we want to solve by a system of linear equations by elimination when we don't have the coefficients of one variable as opposites. So I'll see you in the next video.